after this hardware interoperability problem, I think that I will be able now to show our work. So this is something we are doing at FLE, which stands for Fujitsu Laboratories of Europe. We have the headquarters in London, and our branch is in Madrid. And this is the work that some colleagues and myself have been working on the last year. A bit of context first. We are building a platform for in the financial domain, so it can be used by banks or financial regulators, so that they can get data from multiple resources, which is normally heterogeneous, and to get some analysis on top of it, so to get some insights out of all this data. So why we are building this platform, or why we need technologies, semantic technologies for this? Well, first of all, some important data sets as corporate announcements, for instance, are in some countries are still published as non-structured data in PDF. And it takes a lot of effort to collect and process all this data and to extract the insights that you are looking for. Then this is the public data side. When you go to the private data side, you find that many banks and financial institutions still have their data in silos and usually fragmented. So that's second motivation for this work. And if you really find some common integrated database that you can use, then sometimes you find that the data formats and identifiers are not always standardized. So we decided to build this platform, and at the storage side, at the core, we have a knowledge graph. And what are the benefits here of using a knowledge graph? I think that I'm missing a point. Let me just check. One bullet point is missing because of the font. But this should make it. Okay. So in our case, the using a knowledge graph reduces the time spent by the customer, the user, by integrating the data, because it helps to do the simple and repetitive tasks quicker. I will show you later how we are organizing this. Then data reconciliation gets easier for non-domain experts, so that if we maintain a knowledge where we get, let's say, we keep the knowledge from previous usage interactions there, a non-domain expert user can benefit from it. And finally, it adds extra value to customer information because we are linking new data inputs to the knowledge that is already there. So this is some details about the platform that we were building. This is basically showing that we are getting some financial data, stock quotes, or annual reports in XBRL, which is the format that many countries are using, or the governments are enforcing corporations to publish their financial statements. But also we are getting non-financial data. Can be data about the company, so the address, telephone numbers, and so on. Can be news, can be events, or can be data from the social network. So at the core of our platform, we have what we call the knowledge graph for the financial domain. And what I'm explaining today is the dynamic data loading module. This is how we populate this graph. So when we show this platform to the customers with nice visualization and so on, first thing that they ask is, oh, how I can put my data there? So we decided to build this technology so that we can help them to put their data inside easily. And yeah, so next would be, I hope that the animation is still working, but the fonts are still shifting, but I think that it will work. I'm showing here 4 phases of the dynamic data loading, and with a really simple example. This is a CSV coming from a random data set, and it has, let's say, a list of entities. In this case, are companies, and in the header of the CSV, we have ID, C.name, and employees, and then we have all the documents there. So the first thing that we do is the data property reconciliation. So we look at the headers and try to search in our knowledge base what do we have there which is similar to these headers. This means that if we take, for instance, the C point name, we will do a string similarity with the properties that we have stored in our knowledge graph to look for properties that are similar to C.name, and the properties that are more similar will appear as potential properties to reconcile this header. At the end, what we have, it's a list of reconciled headers. So in this case, for the IDs, we have ticker, which is stock ticker. For the name, for the corporate name, it is reconciled with the name. And for the employees, just reconcile with the employees. What we are doing basically here is to look in our knowledge base what we have and trying to semantically annotate the header of the CSV. So that now our CSV looks, it has like the canonical data property that we are using in our knowledge graph. Second, the potential identifiers finder, what we do is to analyze the columns of our CSV and looking for the uniqueness of their values. This is one thing. Second thing would be to check if in these values we have values which are already stored in our knowledge graph, we will get a recommendation saying that, okay, maybe you can use this column as a potential identifier, which is basically a primary key, or other users suggested that this column is also a potential identifier. In this case, we are just getting that the ticker is a primary key and is using as an identifier. So next step would be the entity type and domain recognition. What we mean here is that when we load the data into the system, the system does not know from which domain this is coming from. It does not know if these are companies, if these are hospital patients, or if, what are these. So basically what we are doing here using probabilistic methods is to search at the data properties that are related to this entity, to search at the values that are related to this entity. So we are able to recognize the entity type. In this case, it recognizes that it's a bank because of the ticker, and also the domain. In this case, the domain would be the finance. This is because we have an annotated knowledge graph with, let's say, from the domain properties of that are normally related to the domain finance. We have a percentage of properties that appear here for this particular entity, so the system is able to infer that, okay, here what we are talking about is a bank and the domain is a finance, a very simple example. In the case of the entity disambiguation, once we have that the entity is a bank that is in the domain finance, that the primary key is the ticker, and so on, we want to disambiguate this entity. In this step, what we do normally is to check what we already have in the knowledge graph again, so previous entities that have been already stored, and how they match the data that it's incoming. So then the system will suggest if this is a new entity, it will just automatically load it and put it into the knowledge graph. If it's not, it will suggest to merge. Merge means that, okay, you have here some data properties that are matching other data properties in the system, so that maybe you want to merge these two entities. So what we are trying here is to make also the human in the loop, and we use a virtual assistant to do that, so that when the system is not sure about what to directly load the entity. It will ask the user, what I do with this? Should I merge? Should I load it? Should I discard it? At the end, from each entity, we are focusing on these 4 properties as identifiers. So the data property, which identifiers we have in the CSV in this case, the entity type, that would be the bank in this case, and the domain, which is finance. And with the disambiguation and the data that we already have in the knowledge graph, the system would suggest that this is the Santander Bank. And finally, we will go to the knowledge-based storage. So how we do store this. What we have here, we are using 3 different storage technologies. So in the property graph, that we are using Neo4j. For document storing, we are using MongoDB. And for the ontologies, we are using Apache Gina. So the idea basically is that some parts of our entity of the data that we get in goes to one of the data storage that we have, and some parts are to the other. But at the end, at MongoDB, we have a central registry that it's the one that we are using to connect all this entity as it is distributed. So this is basically the workflow that we developed. The idea here is that each orange box is implemented as a microservice, and it can be deployed in different Docker instances so that it can run in a distributed environment. But basically, every time that we get new data, we follow these steps to populate our knowledge graph. Some challenges and lessons that we learned here. First, we were struggling with the choice of the knowledge base to store this, or the data storage to store this, and we decided to have this hybrid knowledge base, having a property graph, having a document database, and having a repository for ontologies, or a triple store. And the reason is that some of the, let's say, of the features that we got from one of the technologies we didn't get from others. So at the end, what we decided was to use these 3 different data storage technologies and to put some API layer on top that can help us to distribute the data as it comes in. And as I said, the main registry would be in a MongoDB, which is connecting all the different storage technologies. Another challenge that we got is that we wanted our system to get better with the user interaction, so that it learns from the user actions. When some user says that this data property can be used as an identifier, we want to store this. But then we get the problem of trusting the user. How do you know that this user is saying the right thing and the other is not saying the right thing? So that this is a bit tricky. So what we did finally was to get for each personal user, to get these preferences with more weight, and to consider as a suggestion the preferences of other users as a separate weight, so that when a user has to make a decision, when it comes back to the system with his login, we will use his historical decisions with more weight. And then what the community is saying, it will be like something which is suggested to the user. We also took into account that although there is a lot of manual work of curating the data sets to build the preliminary knowledge graph, once you have let's say that the microservice workflow in place, it can be applied to other areas. So let's say that the dynamic data loading technology can be applied to other areas, like healthcare, that we have some colleagues working on healthcare as well, retail, transport, and manufacturing. And that was all from my side. If you have any questions, thank you.
interesting. Regarding the first challenge that you guys had, I'm just curious what made it a challenge. More specifically, why did it have to be 3 different storage technologies? Why couldn't everything be stored in Neo4j, for example?
So one of the, I mean, it could be 3, it can be 2, it can be 4, it depends. I mean, we decided to use 3 because there were some data that we were not able to store into the property graph as we wanted. So in the case that, for instance, in the stock data, we were having stock data about the companies, and let's say that what we got in the Neo4j to store temporal series of stock data was not like what we wanted to do. To access the data, we had some difficulties, so we decided to store the stock data in a document database as MongoDB. So that was one example of using a document database. But for instance, if you go the other way around, so why we decided to use a property graph as well. So there are some types of analysis that we want to do, like the shortest path between one company and another, that in Neo4j, for instance, comes off the shelf, and in some other data storages, as MongoDB, you have to implement this feature.
Thank you.
Which data sets are more, I mean, which data set that you acquire from the outside are most important for your knowledge graph?
Important.
And are you using, I mean, commercially available data sets, or you use some open?
So this work, so this is at the, let's say, the field trial level, which is like after we build a prototype and some business unit is interested because they have customers and so on, then we go to this field trial. And in this case, we were working with a financial regulator, and the most important data set, the one that we used to, let's say, to create the knowledge graph from the beginning, it's a list of the entities that are being monitored by this specific financial regulator. And this list of entities normally has some corporate details as address, telephone number, and so on. And having this, let's say, backbone in a knowledge graph, then we start to add data from different domains. We are not using any commercial data set, but basically what we are using is public data sets which are from different sources.
Okay, thank you.
Time for a quick question. Actually, 2 quick questions. So the first one, in the entity type reconciliation, what do you do if you have many types in a data set?
We normally at this step we are supporting like data sets that get let's say that has data from one specific entity type. So we are not mixing different entity types per data set.
Well, that must reduce the number of data sets
yes.
quite drastically. So, and then the next question is, you didn't say anything about any manual process in your ingestion.
Yeah.
I assume there must be some parts that are manual. Can you say a few words?
Yeah, I skipped that in the presentation because actually this is like out of the scope of what we wanted to present. But the idea is that we were building a virtual assistant that is the one that gets the interaction with the user. So that when the system tries to process everything automatically or in a semi-automatic manner, but there are some ways where there are some cases where the it's not sure about, for instance, whether merging an existing entity with a new entity that it's getting loaded, or whether the domain of the entity or the entity type is not the one that it's suggesting. So let's say that the probabilistic methods that we are using behind does not give sometimes a clear answer. So then via this virtual assistant, which is actually like, it's asking the user, okay, we have here these 10 cases where we didn't know how to solve them. What should we do here? And this is how we learn of what the user says.